Here's a review problem on the subject of simple harmonic motion, and it also combines a little bit of the law of conservation of momentum as well. This is from the AP Physics Level B exam from the year 1995, and this is problem number 1. If you'd like to take a moment and print yourself a copy, then you can hit pause and resume once you're ready to copy notes onto your own copy of this problem. Okay, so welcome back. Let's jump into it here. We have a mass of 0.2 kilograms that's moving to the right with a speed of 3 meters per second, and it hits and collides with a 1.3 kilogram mass, and they end up sticking together. So this is a perfectly inelastic collision. The first thing we have to solve for immediately before impact takes place is what's the linear momentum of the 0.2 kilogram mass. So this is very straightforward. Momentum is just the total quantity of motion of an object, so all we need to do is multiply mass times velocity. So 0.2 kilograms multiplied by 3 meters per second gives us 0.6 Newton seconds. What's the kinetic energy? Let's answer that up here where we have some space. Kinetic energy is 1/2 mv squared. So 1/2 times 0.2 times 3 squared, we can cancel the 1/2 and 0.2 and call that 0.1. 3 squared is, of course, 9, so we have 0.9 joules. Part B. Now, for the combined mass when they stick together immediately after the impact, what's the linear momentum and what's the kinetic energy? Well, we really don't need to do any calculation to find the linear momentum. The concept is that momentum is conserved, so the answer has to be 0.6 Newton seconds. If you prefer the units of kilogram meters per second instead of Newton seconds, that's fine. Those are equivalent units. So the kinetic energy of the system, well, kinetic energy is 1/2 mv squared. In this case, we have a mass of 1.5 kilograms. That's what you get when the two masses stick together. When you add 0.2 kilograms with 1.3 kilograms, of course you get 1.5 kilograms. Now, speed, we can figure it out knowing that the momentum is conserved. We can find the final speed of the object stuck together. So 0.2 kilograms was moving to the right with a speed of 3 meters per second, and it collides with this other object at rest. Now they're stuck together as one. Notice they use the phrase immediately after the impact, because you see that the second block is attached to a spring, so the spring is going to slow it down, but at the instant right after the collision, the momentum is conserved. So initial momentum is 0.6 kilogram meters per second, therefore final momentum must be the same amount, and if that's comprised of a total mass of 1.5 kilograms, then we can figure out what speed would correspond to that amount of momentum. We just need to divide 0.6 kilogram meters per second of momentum by 1.5 kilograms. Now, 6 divided by 1.5 would give us 4, so mental math, this must be 0.4 meters per second. So that's the velocity we'll use in this formula for kinetic energy. 0.4 squared multiplied by 1.5 divided by 2 gives us 0.12 joules. So the kinetic energy has reduced from 0.9 joules to 0.12 joules. Where did all of that go? Wasted thermal energy in the process of the collision. After the collision, the two masses undergo simple harmonic motion due to the behavior of the spring. Determine the amplitude of the harmonic motion. So we can get this from conservation of energy. So although energy was wasted in the act of the collision, once the collision is done and the two masses move together as one, whatever kinetic energy they have at the instant immediately following the collision will correspond to the amount of potential energy in the compressed spring when it reaches maximum amplitude. So all we need to do is set the kinetic energy equal to the potential energy. In other words, the kinetic energy immediately after the collision but before the spring starts compressing compared to the potential energy in the spring once it's fully compressed. 1/2 mv squared equals 1/2 k. You might be tempted to say x squared, but the value of x in this case is the full amplitude because they're asking what's the greatest distance of compression. The 1/2s cancel out. A squared is equal to m over k times v squared. So A is equal to the square root of m over k times v. In this case, it's the square root of 1.5 divided by 100, all multiplied by 0.4 meters per second. And we get an amplitude of 0.049 meters or 4.9 centimeters. Determine the period of the subsequent motion. Period is equal to 2 pi times the square root of m over k. So this is 2 pi times the square root of 1.5 over 100. And we get a period of 0.77 seconds. Okay, so there's a pretty straightforward problem on combining simple harmonic motion with collisions.